Hello again and welcome to the second visualino video tutorial. When we finished the first one, we had some readings from an analog input. The analog input from an LDR in a voltage divider. So those numbers changing on my screen on the serial monitor are the values for the ambient light in my room, and now, as I did previously, if I cast a shadow, numbers go down. So we decided before to use 700 as the threshold that will trigger a reaction. So I click on monitor and get back to the programming area. Now I have a couple of programming structures to develop. One of them is about the decision process, and the other one is about the reaction, so how the actuator is going to produce a physical output from the control process. So now I have to make some control, and then I go into control. Well, what I want to is to fork the flow of the program into two parts. One that happens if the light detector detects some shadow on it. As we said before, if the reading from the analog input falls below 700, and that can be written in a block like this. If you go into logic, there you get the comparison operator, and you can say if something is smaller than something, what something is smaller than what? The value of the reading which is stored inside the variable. So if the variable sensor is smaller than the threshold that we are setting at 700, if this condition is true, then do something. What am I going to do? I'm going to turn an LED on, because signal LEDs do precisely that, signaling that something is happening. In the same way as I'm signaling by turning on an LED, I could be controlling some other device, turning on some other device. So I'm going to turn an LED on by giving to it 5 volts. How do I give to an LED 5 volts from the Arduino board? If I have that LED connected to a digital pin, as you can see on the course notes in the virtual classroom, you can set this digital pin high, meaning put 5 volts on that pin, and which pin? A digital pin that I choose from pin functions, let's say pin number 8. So if the light intensity goes dimmer, so the input from the sensor gets below 700, then turn on some LED. Well, now once an LED is turned on, once this digital pin number 8 is in a state of high, meaning with 5 volts in it, it remains so till it's turned low. So we should turn it low if the value of the sensor gets greater than 700, because if not we will be having false positives. Then how do we do so? We can do so with another if variable sensor greater than 700, turn it low. Or we can use an if else. If else comes from clicking on this blue star here and dragging and dropping the else under the if. So I'm going to duplicate by right clicking and choose the first item in this list, and then turn the state low. So I can pick low from this pull down here. So now, what's the meaning of this? The meaning of this is this conditional structure, if else, means that if the condition is true, so if the value is smaller than 700, then this happens, meaning the LED will be on, and this does not happen, so it's not off, it's on. And then if the condition is false, meaning if the value stored in the variable sensor, which comes from here, from the reading of the pin, is greater than 700, meaning there is enough life to get above that value, then if this is false, I repeat, then this is not happening, but instead is happening the else command here, which means turning it low. So here we have actually forked the flow of the program into two separated branches, meaning in some conditions, and meaning some physical conditions, if the physical magnitude of the outside ambient light is so the reading is below 700, so this condition is met and true, then this happens. If not, this other thing happens, and there is classic. So either you have one of them or the other, but you cannot have both of them, not one after the other. It is either on or off. Okay. Now, as we still keep the serial print and the weight, we can check that this actually happens by watching our LED connected to digital pin 9 turn on or off, depending on if we cast a shadow or not on the LED, while at the same time getting the values above or below 700 in our monitor. And then after we have properly checked that this is happening, that we get it on when we cast a shadow and off when we don't, then we can remove the weight and the serial print, and that way we will be getting, and then reunited the code of course, we will be getting a much more responsive system without the delay included there. Okay, on the right side you can see the new structure being typed there as new lines of wiring with the if condition inside parentheses, and then the else there with the digital right. Please notice the lowercase and capitals there, all that syntax is lost, and it's so much easier when we just use the blocks. We don't have to remember the precise details of the typing there. Okay, so now we have used an analog input with some values that change continuously to produce a digital output, which is something with just two states, either high or low, nothing in between. So this binary reaction is a truly digital output. It's either on or off, and it's the reaction to the analog input, in which we use a threshold to separate two areas of values for the sensor readings. That part can be discussed in more detail at the virtual classroom, as always. Okay, thank you for your attention.